Hey everyone, this is your weekly episode of the Zephyr podcast where we talk about all things Zephyr, embedded, and other cool stuff. I'm Benjamin, your host.
And I'm Fabio, your co-host. And Benjamin, you're late.
Well, we have a new sponsor this week, Cloudflare, basically as a sponsor, and I was chatting with them, and basically they shut the entire internet down
Again.
right as we were again and again. Did that happen twice? But yeah, it was pretty bad. We were just about to hop on the podcast recording platform thingy, and yeah, half of the internet, if not more, was down again. But yeah, of course, we
Down
don't have a
down
sponsor.
detector
It
was
was just a bad
down.
joke.
How do you
Yeah, down detector was down. So,
There's a down
but yeah,
detector for down
yeah,
detector.
yeah. I'm not sure that ever happened before, but I'm sure there's lessons to be had there. How are you? What have you been up to?
Yeah, good. Lot of discussion going on this week. Lot of talk and not much code, to be totally honest. But some weeks are like that. What about yourself?
Yeah, I'm doing good. I've been spending some time on the documentation again, among other things. Zephyr has a pretty extensive documentation, and a lot of it is powered by something called Sphinx, which is a Python framework for all things documentation. Some of you might be familiar with Sphinx. I mean, some of you are contributing to Zephyr, so you interact with Sphinx. But yeah, it's been used. It's being used in many big open source projects, the Linux kernel and the Python community. CMake also uses it. But yeah, the other day, one of the maintainers was actually organizing kind of an impromptu Google Hangouts session, and so it was really nice to see people from all around the globe showing up and like sharing their thoughts about how they use Sphinx. I think yeah, there were folks from again the Python community, the scientific community in general. I think folks from Google were there as well. I think Pigweed uses Sphinx as well. So people sort of like sharing their wish lists and so on. And there was one guy who's like super active in the community developing Sphinx themes, and the comment they were making was that if you go to the Sphinx homepage, it's like it's using basically it's dog fooding, right? So it's using Sphinx for the actual website and the default theme, and it feels very old, very dated, like as in very dated even. Like it feels like it's like HTML 1.0 from almost like from 20 years ago. And is it really a good thing? Because it maybe doesn't do justice to the fact that it's actually a really powerful framework that, if you want to, allows you to build like really modern, responsive websites and whatnot. And maybe it doesn't show. And for people looking at setting up documentation in their projects, they do their sort of due diligence of what's out there, and chances are they might find some other like React, JavaScript, whatever, new kid on the block stuff that looks maybe more appealing, at least from a quick look. And so yeah, the discussion was like, should Sphinx have a better like default theme, just to better reflect that it's like it's aligned with the sort of like the state of the art of like what can be done to make good looking and like powerful websites. And we have kind of like the same discussions uh, in the Zephyr community, where it's it can be a challenge to find the balance between, hey, let's really focus on the content, and I mean, Zephyr project is not in the business of shipping websites, certainly not. So documentation should be pretty straightforward, um, but we can also make it look maybe slightly better, and make it easier for people to realize that, hey, we are we are active. Like we care about the whole thing in the project, including making sure that the documentation looks good. Then define what looks good means. But so yeah, that's what I saw happening in the Sphinx community. And like I was mentioning last week, spending a bit of time. I think it's now live. We were discussing that, but the homepage of the documentation has been reworked. A few other areas I'm hoping will be sort of redesigned similarly. And also working on CMake documentation. That was a long
Nah,
monologue. You have
uh,
tons of
it
questions,
was
Fabio,
good.
I hope,
I,
please.
I, I think you touched a very interesting topic while discussing the whole Sphinx story, which is that the project is not in the business of building a documentation infrastructure or a development infrastructure, but sometimes it's something that we have to do because of the size of the project. Whatever we have available may not be scaling enough, and we've seen that, for example, with all of the support stuff that we did around the pull request. We had two separate dashboards that we uh, did from scratch for both merging and just for giving something to the maintainer to work with. And this is definitely a topic for documentation as well. So do you see, have you seen a significant amount of upstream work on Sphinx that started from Zephyr? Like, did you upstream something that we did originally downstream?
Uh, Personally, I've been fixing a few things either in Sphinx or what's also interesting with Sphinx. I'm sure like many other solutions out there, but it's basically like a core infrastructure, and then there's extensions, and like it's really meant to be like this sort of plugin approach where you can have additional extensions for supporting this and that. And like I was saying just before, one thing that I hope to add in the near future is support for documenting CMake stuff. There is a CMake extension, Sphinx extension, which is effectively part of CMake upstream. They do have their own extension, which anyone can pull in into their Sphinx-based documentation. And I found a few bugs in there, so I've been contributing to that. But it's one, just like in general, it's one of those projects that are like pretty stable.
Mm.
I don't have the history in front of me, but it's been there for at least a decade, if not more. So there's not like that much new features happening anymore. It's more, yeah, the work is more about like keeping it fresh, or like whenever there's like new major Python versions, migrating, like dropping support for old end of life versions and stuff like that. But it's yeah, one of those projects that just do the job and you don't have to tweak all that
So
much.
the extensions you're referring to are the thing that allow you, for example, to refer to a device tree compatible, and then you get the link and the pretty printing, right?
Yeah, it's like it's so I guess rather than documentation system, maybe some people would call things, it almost falls into the realm of CMS, right?
Right,
Like content management systems. It allows you to really like think about what are your sort of first class citizens and first class entities in your domain. And so there's a bunch of general ones, like uh, you have pages and you have like sections in the documentation, and so you want to be able to link to those like basic entities, or you have terms that you define in your glossary, like those are standard entities. And then there's more, like you have also standard entities for all things C as part of the
right.
so-called C domain. You want to be able to describe functions, macros, structs, and so on. So in this Zephyr documentation, we would use the C domain, and basically we use it in a way where if in the Zephyr documentation proper, one wants to make a reference or a mention of something that's effectively C stuff, they use the proper Sphinx construct for that. And then under the hood, what happens when we build the documentation is that it automatically, whatever link someone wants to make to a C struct, it turns into a link to the Doxygen documentation. It turns into a fancy pop-up. When you over the link, it shows you the right thing. But yeah, the C domain is like very standard and well established. Python is another one. CMake has one, which we will be, I guess, piggybacking soon. And then we have our own Zephyr domain with our own first-class citizens, like code samples, boards, device tree
That's right.
compatibles. This is actually a Zephyr thing, but we could make it as an extension. Like you're making me realizing that we do have yeah, sort of our own standard way to describe a device tree compatible. It lives in our own infrastructure, but we could make it a standalone extension that anyone interested in manipulating device tree as first class objects and entities in their documentation could be reusing.
So
Kconfig is
yeah,
another one,
the
etc.
stuff is cool. If anything, I know you guys are very involved with developing the documentation infrastructure. If anything, when I'm writing the embedded documentation for code, I find that there's a lot of stuff. And do we have like a cheat sheet or like a reference page for the tag you can use in the documentation? I think that could be useful for me.
Yeah, we do. I think I hope it's mostly complete, but we have documentation writing guidelines. So which is kind of a mix of some advice and guidance. How should you use the English language, and like how should you structure your documentation at a high level, and then what's available to you in
Yeah.
terms of all those
How do you
fancy
how do
things
you reference a C macro or a
in Sphinx.
function or a device tree?
Yes.
Good
Yeah.
stuff.
Industry news at large, many of which are like very related to Zephyr. Uh, GitHub.com// Mercedes Benz. It does say on the
I
notes I
think they
have.
make cars.
Yeah, I think they make cars, and that's what I'm seeing in the notes that we both shares. GitHub.com// Mercedes Benz/RDEP. And if you go there, it says Zephyr, 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 and it has like a West manifest and so on. Like, what is that? Automotive rapid development platform.
Yeah, this showed up on GitHub, and both of us, somebody gave us, two different person gave the two of us the link to look into. So it looks like it made some noise. Yeah, thanks for the tip. You know who you are. Good stuff. Yeah, so it looks like Mercedes, which, as you may know, they make cars. They published this project called RDeep. It looks like it's being developed by a contractor. I forgot the name, but um, I'm not sure what it does, but it seems to be a framework, like middleware kind of platform that implements a bunch of libraries for doing development on the car infrastructure. I presume this is the body bus, as it seems like it's called. So not the critical engine stuff, but everything else that is going on with the car. So I took a look at the code base, and it's it looks like they got the whole Zephyr philosophy of how to implement stuff. They nailed it. So there's a library called UDS, Unified Diagnostic Services, and it implements a bunch of stuff. And you can plug things into it using iterable section. So it seems like this is a thing that they used for building application on top of it, and they have the whole modularity of the system done properly. And the repository has CI integration using the provided action. So like they did their homework. It's great stuff. Everything is around Canvas, obviously. Now Mercedes is the first company that that actually sold a car using Canvas that has been developed by Bosch at the time. I think they developed it for them, and then it became pretty much an industry standard. And one of the interesting thing is that they integrated the connectivity package into their system. I don't know how the board that it looks like they do have a board that they use with this library. So this is probably something that they give to their the internal teams, and probably outside team as well, since they published it. And the board is using an STM32G0. They reused the Zephyr library to expose the Canvas interface to the host. So there's definitely, I'm sure they have a application level counterpart for this board. And the other cool thing I spotted is that they are using a secondary chip running Blackmagic Probe as a onboard debugger. So basically, they built an entire custom development kit with the source code level debugger included, using all open source stuff. And it's great to see. That's a good
Yeah, like I mean,
project.
from what I see in the repo, like like you said, they seem to have a custom board, like the RDEP board, and they have extensive documentation for it. Like I wish all our boards had something like that. Like it has like all the schematics and I'm looking at the schematics right now. One thing that you might not have realized until I'm gonna say it, but it's CAN interface and it has lean as well. which is kind of
Oh
interesting
yeah.
because that's also an interesting news from this week in Zephyr land. Lin is basically, and I guess I forgot to took note of like what the acronym actually stands for, but it's an ISO standard, which is kind of like the a cheap or like a simpler version of CAN, like a single wire bus for the low bandwidth body electronics. We were talking about the body, so like mirrors, seats, whatever in the car. And so looks like this Mercedes thing is using it, but kind of like interestingly, and I don't think that's the same people at all from what I see. We had an RFC this week from I think it's yeah, folks from Renesas who are proposing to introduce a new Lean driver API. So it's actually local interconnect network. Now I see it in my notes, and so yeah, this might be coming to the Zephyr, and I guess we should loop in the Mercedes folks so that they provide feedback if they have not already. But that's it's interesting to see all those
Yeah, they
automotive news this week.
Yeah, they could probably work together. Now that you pointed out, I think I remember that one of the things that they implement with their toolkit is a lean to CAN bus integration. Like if you don't know, I haven't worked on automotive application myself, but you have a rough idea of how things are. And my understanding is that normally the main ECU of the car are connected via CAN bus, but the CAN bus transceiver are somewhat expensive. The wiring is meant for longer distances. It's a differential pair. So what happens normally is that the CAN bus connected ECU can branch out into smaller nodes that are connected via LIN, which is basically a fancy UART, and then you don't have a transceiver to deal with, and it was perfectly fine on short distance. So it seems like there is interest in having a subsystem for LIN because these automotive chip is very common to have a few LIN interfaces, and yeah, it's good if they can collab and yeah, come up with with a good API for LIN as well.
Yeah, and just back to the Mercedes stuff and like this GitHub repo they have, which is effectively like a something that anyone could pull into their Zephyr workspace if they want to use bits. Like it's really well structured. They have libraries and like shields, etc. This can to lean stuff. My guess, I'm not 100% certain, but my guess is that it's something that people can just pull into their existing projects. That reminds me that documentation-wise, we have this thing in the Zephyr documentation where we document the list of projects out there that are effectively like open source, or not necessarily like open source, but like projects available for people to easily add to their existing West manifests. And so we have this in the documentation. Again, that's also something that's now very prominent on the homepage. But do you want to like if you want to pull Wolf SSL, or if you want to pull EM learn for machine learning or connectivity and things like that. Like this is we have basic documentation and instructions in the Zephyr website for that. We should probably add the Mercedes stuff, and I guess it's a long way for me to say if you're listening, if you're maintaining a project that is effectively um, a, a Zephyr library, a Zephyr module, some kind of like out of tree driver subsystem, whatever, and you would like to sort of promote it and make it easier for people to know it exists, please do check out the dedicated section of the documentation website and add yourself there. Like send a PR. We we see there's actually like at least once a week there's people adding stuff. I think this week was Wolf SSH, someone adding that. We have Gray Bus that's probably coming as well, um, and yeah, I would love to see more. It's now like 10 or so,
Y-
and yeah.
Yeah, these are good to have as a reference. Even if you don't work on automotive stuff, you may still be interested into studying how they organize the project and just copy paste bits for your own. So good job, Mercedes.
Yes, totally. Yeah, yeah, it's awesome. So something else, moving on. What should we pick next? I think I saw something on LinkedIn that was kind of surprising, but really nice to see. Some of you, many of you probably know of MQTT, as in this now 2+ decades old, well, probably turning 30 soon, actually. But yeah, a messaging protocol, like a PubSub sort of protocol for all things IoT and all things like telemetry, and really, really nice protocol that's available in all major cloud IoT platforms out there. That has really good support in Zephyr 2, mainly. Well, actually, like very much TCP based, which can pose issues in some like constrained networks, topologies, and so on. So there is kind of like a little brother or little sister to MQTT, which is called MQTT-SN, MQTT for sensor networks, which is more meant to be MQTT over anything. Like you could do MQTT-SN over UDP, over UART. It's like much yes, like smaller packets, some like techniques for shortening the different the topics, etc., like having setting up aliases for the different whatever, basically something that makes MQTT smaller. And in practice, MQTT-SN has been this random-ish PDF and random-ish specification that's never been like properly ratified, and yet that had some implementations here and there, including in Zephyr. But yeah, people could definitely use MQTT-SN, but it's not like it was as standard as MQTT is. MQTT is an ISO and an OASIS standard. But yeah, MQTT-SN, long story short, the OASIS working group that's looking at standardizing all things MQTT is apparently going to be spending time reviving and resurrecting and I guess properly standardizing MQTT-SN, which I think is quite interesting because I think it's very relevant and like providing like a real um, a path for folks to have their 15.4 based networks, like constrained networks, use MQTT-SN and then route the data to a proper MQTT, good old MQTT network. Could be quite cool. So yeah,
Interesting.
that's the news. Check it out that's and provide input, because I know people, myself included, like MQTT-SN is really nice, interesting, except it's not standard. So you never know whether you should sort of like commit to using it because,
Yeah,
yeah.
it's tricky enough. Yeah, versions and everything. Good stuff. Okay, so I'm gonna pick one from the in progress list. So this is something that I'm not sure why it got assigned to me, and I'm working on it, and I thought, oh, this is interesting. So the Realtek folks, they are working on integration for two of their families of chip. They got the HAL integrated, and now the code is under review. So I'm going to give them a shout for the Amoeba D family of SoC. So Realtek is not historically one of the common platform you see for like maker type devices. Like I think that they tend to have had a closed ecosystem for their stuff, but it looks like they're this is going to change, and they are going to have Zephyr support for a bunch of stuff. And this one in particular, it looks like it's a system on a chip with integrated Wi-Fi, both 2.4 and 5 gigahertz, and Bluetooth as well. Why I think this is interesting? It seems like 2.4 gigahertz is on Wi-Fi is slowly fading. Like I'm starting to notice. I'm starting to paying attention to this, and you see less and less network supporting it and going 5 gigahertz only for good reasons. I don't think we have a lot of options in three if you want 5 gigahertz Wi-Fi for embedded. There is one ESP32, the Nordic 701 chip, I think, supports it. Maybe some of the iRock. So this is going to be another option. I'm looking forward to the integration for this one. It's going to be cool.
Yeah,
It'll
and
make it fun.
you know firsthand, I think that
Yes.
it is it's more than slowly fading out. Like if you go like at things like Zephyr Developer Summit,
Yeah.
and you come with your Zephyr-based Wi-Fi um,
Traffic light.
thingy, and it has 2.4 only, then the conference venue they don't do 2.4 because they
Uh,
it just doesn't scale, doesn't work anymore. And
y-
so
yeah, the background is that I went to ZDS with a demo, and I pulled it off my backpack in front of everybody, and nothing worked. And yeah, I had to rush back to my hotel and come up with a 2.4 gigahertz bridge for the Wi-Fi network, but it worked at the end. So yep,
yeah, yeah. Well, but that's all, and that's also why I mean, conference Wi-Fi now works basically, right? Remember, like a few years back, you would go to the conference and then keynote starts, and you're forced to listen to the keynote because the Wi-Fi just dies when people connect their 3, 4, 5 devices. Now with Wi-Fi 5 gigahertz, yeah, it's not a problem anymore.
it worked.
One thing you're making me think. You just mentioned the sort of like the real tech like story and how like they're going more open, etc. Kind of related, I guess. Like we see more and more Zephyr job postings, and shout out to Qualcomm. This week they were, and this was also shared on Discord. If people are looking for a role as a senior staff engineer at Qualcomm to work on all things Zephyr, it looks like they are hiring, and that combined with other like recent news from the Qualcomm front. I mean, this is interesting moves, and it will be interesting to see how this plays out over the next few months. But yep, we will put the link to the job. I think it's actually remote friendly, at least North America slash Europe wise. There's lots of flexibility. So yeah,
Yeah, maybe worth calling out that there is a channel in Discord for job posting, which is hash job posting. There's also a channel for the
yeah,
podcast, which is hash podcast.
is also okay. Yeah, yes, totally. And that yeah that channel, people should feel free. I mean, it says job posting, but it's also okay, I guess, if you want to offer your services. Don't sort of like abuse it, but it's I think it's a great way. Like it goes both ways. Like if people are on the market with Zephyr skills, they should also engage there. Yep.
Yeah, Qualcomm has been in the news recently for various reasons, but honestly, what I've seen is from them is positive. At least they're doing the whole Arduino stuff, and I think I've seen that they have a new SoC, which seems like they landed the support upstream immediately. So come on, let's give them a chance. I think they're doing the right thing. Then time will tell.
Exactly. Yeah.
Okay,
All right, let's pick a few other Zephyr news, Zephyr hardware or changes. PWM, it looks like PWM API now also supports interrupts, and this was added to the SAM, the microchip SAM controllers for now. We'll put the link if PWM is your thing. This might be an interesting change. Did you spot a few? It's still really slow on the board contribution front, but we were talking about Zephyr in cars. Looks like we have some
we need to aim
Zephyr
higher.
in space kind of boards. Higher.
Yeah, yeah.
Well, there are cars in space, I guess, technically.
Oh, yeah, let's not
Um,
get there. So we have a new board from
yes,
the Space Cubics folks, and yeah, this one has it all. This is a dual Cortex R5 plus a dual A72 with Linux plus an FPGA. So yeah, great stuff.
designed for harsh environments such
Of
as Earth orbit
course.
and lunar missions.
Is
Yay.
the SCOBC module V1. It looks like they have the A1 and the V1. Interesting product naming. It looks gorgeous. It looks like something you would send in space. So yeah, not a ton going on, but yeah, I think it looks like they're gonna sell this thing next year. So if you need to send a board into space with a lot of processing power, that's it. That's one for you.
Yeah, and I'm pretty sure, and this is kind of like a reminder to self. I am pretty sure the folks behind this have agreed in principle to do a tech talk about it. So we will be trying to schedule that because yeah, this is really
That
cool stuff. And if this is also an excuse to talk about FPGA, I'm all for
yeah,
it.
that's cool. Okay, should talk macros. We love macro. It's Zephyr macros everywhere.
Oh yeah, we love spelling out like complicated macro names in a podcast so that people try and like remember, oh, what was the macro called again? Oh,
So
it's called cont
case
case one.
one. So
Okay.
so why do we love macros so much? Is because they allow us to process things at build time. And this is an embedded project, right? Like a lot of devices have limited amount of flash. So if we can pull tricks for optimizing on flash, we do it because we have to. Like once you run out of flash, there's nothing you can do. So one of the thing that we have is something called, I can't remember, it's something else, cond if one or something like that. You can check, for example, if you have a kconfig option set and then expand into something or expand into something else. What's the problem? Sometimes you have multiple conditions, like a case, like what we normally use in a C case. So what happens is that you do the condition one, and then if in one of the two choices you do another condition and then you do another condition and you do another condition, and then they nest every time, and then very soon you're going to need an ultra wide monitor to read the code. It's horrible, don't do it. The nesting is just brutal. So Peter came up with this thing, which I want to use everywhere now, which is cond case one uppercase. We'll link it in the description. And this is a very fancy way of doing kind of like a case thing in macros. It is statically expanded, so you can only do it up to like 16 or 32 conditions, I think. Ooh, I don't know how we came up with this, but it's sure it's gonna be useful. We're gonna use it
Yeah,
eventually.
you basically give a list of pairs of condition. Like if this is true, then I'm gonna expand to this. If else, it's gonna be this, and else it's gonna be that. And so you end up just matching only one thing, I guess. Yeah, no, that's quite nice. And well, yeah, we'll be linking to the PR. Just look at the test case basically, and you'll immediately get how this is being used. And this makes, I mean,
Makes
this
a
is
lot of
super
sense.
readable. So there's that. That's
Yeah,
yeah, that's super
yeah,
cool.
yeah. This is gonna be used a lot.
More macros.
More macros, of course. We can always use
Uh,
more.
all right, and
More
more
drivers.
spelling out stuff. MFD, RV3032 MFD
MFD.
driver. Like what is this? What is this guy? And like
What is
I think
MFD?
MFD, it has nothing to do with the part itself, right?
Yes.
MFD is multi-function devices.
Yeah, yeah. So this is an interesting part as a start. Like, so I pull request and thought, whatever. It's a real time clock. This looks like a fancy real time clock. So the part is described as a high performance temperature compensated real time clock module. I did not know such a thing existed. Normally, when you get like temperature compensated crystal or ovenized crystal is for precision measurement stuff. So I think this is something that you would use if you need a reference clock with a low drift situation. Fancy part is pretty expensive, nice package. I like this stuff. What is MFD? So this thing includes multiple. It includes feature that falls into multiple subsystems for Zephyr. So the MFD concept, the multifunction device, is something that we borrowed from Linux conceptually. And the reason why we do that is that sometimes you have some common code that you want to use for the driver in the individual subsystem. Typically, that would be the register access for the device, read register, write register, potentially with some locking in the middle. So in this case, it falls under multifunction device. It's really a real-time clock, but it includes a temperature sensor and a counter. So you have effectively three driver and a common one in MFD. If you're working on a device that it needs API multiple subsystem, this is the way. This is the way to go. We so
And it's common code and also common configuration, right? Like in
Yeah,
your device tree, this is effectively all the same, in this case, I squared C device.
but
And so you don't want to like sort of like duplicate the configuration unnecessarily, like you would have to if this were to be like different
yeah,
drivers,
in
right?
the device tree, this would be nested. You would have a root node for the I2C device that specifies the address, and then you would have child nodes for the individual functionalities because the child node is associated with the struct device that you use to call the subsystem specific APIs. So it's a elegant way of doing it.
Yeah. What else? And another, like, did you want to talk to TPS 55287? I think I'm basically, so folks, I mean, please just give us feedback as to whether you would like to hear more of like those like discussions we sometimes have regarding hardware. You would like to stick to stuff that's really just Zephyr, 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 and you don't care about the specifics of the electronics. Here, this one, I think we're going to use basically as an excuse, as we tend to often do, as an excuse to talk about like what this means therefore-wise. So this is like a voltage
Yeah.
regulator
So
part, and I guess this maps to some interesting concepts we have in
yeah,
Zephyr.
this is a fancy one. So the driver falls under the regulator subsystem. And so this is a set of API that you can use to control a regulator. So you have like a power supply, and you can define the voltage if you can change it dynamically, or the current limit. So this is normally used for either PMIC or embedded regulator, and you can set the parameter and change them at runtime. So I think this specific part is interesting because it's fancy. It's not like most of the stuff that we have at the moment are low voltage, low power stuff. This one is not. This is one of the weird TI TPS devices where the inductor can be configured dynamically in a buck or boost configuration. So you can either step up or step down the voltage, and it's a wide range 36-volt input and 8 to 22 output with a 4 amp limit. So you can pump 80 watts on this thing. And the integration with the regulator interface allows you to enable and disable it and change the voltage of the device in 10 millivolt step. I think this one is interesting. I'm traveling at the moment. I have a return flight with a couple of hours. I think I'm planning to do a board with this one. I think it's a cool part worth looking into. TPS 55 to 87. Link in the description.
Yeah, TI part, and I'm briefly glancing at the code. So yes, you can like set the voltage, but aren't there typically also like a way to like limit the current?
Yeah,
It doesn't look like this is
yeah,
implementing that
yeah.
now.
So it looks like the initial pull request is on does only has power control on and off and voltage control. We have the API for current limit, so it'll be interesting to have. And maybe I'll do it myself. That'd be cool to have it.
Yeah, right. Yeah, yeah. Like I was
Yeah,
just basically asking for
yeah,
confirmation, but yeah, the regulator API also allows to deal with current and
yeah.
not just voltage. So yeah, cool. I think that's it for this week. Next week, personally, I'll be off to Paris for an open source conference,
Cool.
and the reason I'm mentioning it is that I will be so I have a short or reasonably short presentation on the Cyber Resilience Act, for which I need to still prepare my slides. But I'm mentioning it because this week, and we will add the link to the notes. The European Commission published a bunch of resources around CRA, which I think are relevant for many people using Zephyr. So like some FAQs, and I think they even like launched some kind of website that makes the various uh, texts more accessible to mere mortals. So yeah, keep an eye on that if you haven't seen it. It's really like it was released, I think, the day before yesterday or something. So yeah, CRA in Paris next week, but we will be recording a new episode next week for sure. So yeah, join us on Discord, in the comments, like, subscribe, and yes, and share your feedback.
Bye.
Bye.